Today we'll be talking about properties of parallelograms, and basically all a parallelogram is, and I'm using the example over here which is PQRS. All a parallelogram is that both pairs of opposite sides are parallel. And the way we can indicate a parallelogram when we're writing is to draw a small little parallelogram. Excuse me on that one. That's horrible because of me trying to learn how to write with this pen. But you do the parallelogram and then PQRS. So you just say the points. And then when you're drawing a parallelogram and you want to indicate that it is a parallelogram, you do these little arrows to indicate that these two sides are parallel, and then you do this arrow to indicate this is parallel with this one. Let's look at theorems about the parallelograms. So we have our first theorem, 6.2. If a quadrilateral is a parallelogram, so that means a four-sided figure is a parallelogram, then its opposite sides are congruent. So therefore, PQ, so we have PQ right here, is congruent to RS. It's the same length. And QR, this side, is congruent to PS. For theorem 6.3, if a quadrilateral is a parallelogram, then its opposite angles are congruent. So therefore, angle P is congruent with angle R. So if angle P were 40 degrees, then angle R would be 40 degrees as well. And angle Q is congruent with angle S. So opposite angles are equal. Theorem 6.4 states if a quadrilateral is a parallelogram, then its consecutive angles, remember that one means right after one another, are supplementary. So in this instance, we have a quadrilateral. So angle P and angle Q should add up to be 180 degrees. And angle Q and angle R should add up to be 180 degrees. And angle R and angle S should add up to be 180 degrees. And then S and P should add up to be 180 degrees. So they're supplementary. Theorem 6.5, if a quadrilateral is a parallelogram, then its diagonals bisect each other. So that means these two lines going from the vertices, they bisect, which means that these segments like MP and MR are going to be equal to one another, and QM will be equal to MS. Okay, let's apply this. So an example problem that you might face is FGHJ is a parallelogram. Find the unknown length. Explain your reasoning. Okay, so let's look at the first unknown length. We have JH. So we want to find out what is the length of JH. So we're going to be looking at where JH is, and it's down on the bottom here. Remember that opposite sides in parallelograms are equal to one another, so therefore I can state that JH is equal to FG. And FG equals 5, so therefore JH must equal 5. And I'm just going to say here for my justification, opposite sides. Let's look at B. So JK. And I have JK going like this. So it's one of those diagonals that's getting bisected. So remember that your diagonals are going to be equal to one another. So JK should be equal to GK. And since GK equals 3, I know through substitution that JK equals 3. And I'm just going to state that as diagonals. Okay, next example. PQRS is a parallelogram. Find the angle measures. So we know from our from the theorems that two angles next to each other, the consecutives, are supplementary, so they should equal 180. So let's look at the measurement of angle R. We want to find that. So we know over here the measurement of angle R is actually equal to the opposite angle. So we know that the measurement of angle R is equal to the measurement of angle P. And we know that angle P is 70, so therefore the measurement of angle R should equal 70 degrees. And I would just justify that by saying opposite angles. Let's look at B. So I have the measurement of angle Q that I want to find. Angle Q is right here. It's right next to this other one, and it's right next to R. So I know that measurement of angle Q plus the measurement of angle P should equal 180. I know that P is 70, so through substitution I can plug that 70 in there. And now, property of subtraction equality, I'm going to subtract. So I have the measurement of angle Q equals 110. And I'm going to just say supplementary. Alright, let's look at some more difficult things which involve proofs. Alright, so here's some examples of proofs that you might deal with parallelograms. So given ABCD and AEFG are parallelograms. So we have A, B, C, D, this one, and A, E, F, G, this one, are both parallelograms. We want to prove that angle 1 is congruent to angle 3. So the plan is show that both angles are congruent to angle 2, then use transitive, property of congruence. So what they started with was, they said, okay, ABCD is a parallelogram, and AEFG is a parallelogram. That's given. We always start with our given. The second thing that they're going to state is that angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3. And the reasoning for that is opposite angles of a parallelogram are congruent. Then they end with angle 1 is congruent to angle 3, and that's just transitive property, because if you know if 1 equals 2 and 2 equals 3, then 1 therefore must equal 3. Here's another example of a proof. Given is ABCD is a parallelogram, and they want us to prove that the line AB is congruent to CD, and AD is congruent to CB. So let's start out. So we just state our given, ABCD is a parallelogram, given. Then what they did was they drew the diagonal from B to D, and what they said is through any 2 points there exists exactly one line. So you can always draw a line between 2 points and use that as your reasoning. Then the third one, AB is parallel to CD. So we go, okay, AB is parallel to CD, and AD is parallel to CB, and that's the definition of a parallelogram. They gave that to us. So number 4, they said angle ABD, so this guy, and is congruent to CDB, which is this guy. And also ADB, so this one I'm going to do double on that one, is congruent to CBD, this one. And the reason I know that is I drew that diagonal, I have 2 parallel lines. So that's alternate interior angles theorem, that the alternate angles are equal to one another. Then I'm stating that the line DB is congruent to DB, and that's just reflexive property. Remember, when they share that line, you can use reflexive property. And now I'm going to state that triangle ADB is congruent to triangle CBD, and that's angle, side, angle. So we have angle, side, angle that they share. So they're congruent. Then I state the last thing that I want to prove. Line AB is congruent to line CD, and AD is congruent to CB. And the reasoning for that is corresponding parts of parallelograms are, corresponding parts of congruent triangles are congruent. And we'll work with this on Monday. Have a good night.